Hi, this video is to show and illustrate how to do metric conversions via unit analysis. Now, first of all, step one is you have to figure out what your starting point is and what your end point is. The question that we're going to be looking at is how many centimeters are there in 17.1 miles? So we rewrite that with our starting point and end point. Now, the starting point is the number in units provided in the question. So 17.1 miles. Remember, when you abbreviate miles, it has to have the I as well as the N. And then the question is, how many centimeters is that? So we have our starting point and end point. Second step is that we have to look up and write down our equalities. Now, for metric conversions, we utilize the metric conversion table in order to do so. Now, there are two sides. First, we look up on the left, then we will look up on the right. Now, we start off by looking up the non-metric unit along the left-hand side of this chart. Now, in this question, remember, metric units always end in mg or L. Meters, grams, or liters. So cm, centimeters, this is the metric unit. So our first step is to look up the non-metric unit, in this case, miles. So using the left-hand side of the metric conversion chart, we look up and write down the entire equality. We find miles, and we write down this entire equality. 1 mile equals 1.6 kilometers. So 1 mile equals 1.6 kilometers. Now, once we have that, we now go to the second step, in which we utilize the right-hand side of the chart. Now, at this step, we need to look up any metric unit that has a prefix in both the original problem and the first equality. So we look at this, centimeters. Centi is the prefix. So we need to look up both centi and, since this is kilometers, we need to look up kilo. And we do that by using the right-hand side of the chart. On this side, first one we're looking up is centi, little c. You can either look it up by the abbreviation or by the prefix itself, centi. And we write down the entire line. Now, notice how it says 1 base unit, gram, meter, or liter. Well, you have to think about it and look at the units themselves. This problem, we're looking up centimeter. Centi is the prefix, meter is the base unit. So because it's meter, instead of 1 base unit, I write down 1 meter is going to be equal to 100 centi dash. And instead of a dash, I put down meter again. So from that line, I write down 1 meter is equal to 100 centimeters. 1 meter is equal to 100 centimeters. So this, because that was centi, I've written down this line. Now I do the same thing with this line as well. Because that's kilo, I look up kilo on my chart. I find it here, and I write down the entire line again. 1 base unit. Again, it's still meter since it's kilometer. Remember, if it said kilogram, I would be looking up grams. But it's not, it's kilometers, so it's 1 meter is equal to 0.001 kilometers. So I write that down. 1 meter equals 0.001 kilometers. Now that I have all of my equalities, I now go and set up my grid. Now when I set up the grid, remember that your starting point always goes in the top left-hand cell of the grid. So I have 17.1 miles. you always write the number and the unit. I draw the bottom line of the grid and my first vertical line. Now remember, when we're done, we're going to have one vertical line per equality. 3 equalities, 3 vertical lines. Now, to set up the grid, remember the whole point of unit analysis is that you want to set up your grid so that all of the equalities cancel out except for the equality of the endpoint. In this case, centimeters. So when we're all done, everything should cancel out except for centimeters. Now, how that is done is that I look at each step and I always write the same equality, I write the same unit diagonally. The fact that there's miles here means that I want to have miles down there so that they can cancel out. So I look for miles. I look for all amongst all my equalities, and I find it here. It happens to be the first one. So the fact that it says 1 mile, I write down 1. So continuing, I have, because it has 17.1 miles, because it has 17.1 miles here, I write 1 mile down here. And what it's equal to, in this case, 1.6 kilometers, that will go on top. So 1.6 kilometers goes on top. Now, once I use an equality, I cross it out and I do not use it again. I have another couple of equalities, so I write down another vertical line. Now I do the same thing again. I have kilometers here, so I want to write down kilometers there. I can't use this one, I've already used it. So instead I use this one here. And I write down the entire thing, 0.001 kilometers. And what it's equal to, 1 meter, goes on top. And once I use this equality, I cross that one out again as well. And I have one more equality, so one more vertical line. I have meters here, so I want to have meters down here. I look for meters, I can't use this one, so I have to use this one. So I write down 1 meter and what it's equal to, 100 centimeters. Now I make sure that I set up my grid correctly by making sure everything cancels out except for the units that I want to end up with. So miles cancels out with miles. Kilometers cancels out with kilometers. Meters cancels out with meters. And I end up with centimeters, which is exactly where I want to end up. Remember, if you cannot set up the grid correctly, if things don't all cancel out, chances are you wrote down your equalities incorrectly. So you should try that again. Now, once you've set up your equalities, next comes using your calculator. Now, the whole thing is set up so that you can do it all at once on your calculator, pushing as few buttons as you possibly can. So on my calculator, what I'm going to do is you take your first number, you go cell to cell. If it's on top, if the number's on top, you multiply. If the number's on the bottom, you divide. You ignore the ones. So I take 17.1, I go to the first cell. The 1.6 is on top, so I go times 1.6. I don't bother pushing equals, I move on to the next cell. Now the number's on the bottom, so I go divided by 0.001. And then I go to the last cell, the number's on top, so I go times 100. And I push equals. Now, the number that I have, 2736000, is still not quite the correct answer. Remember, the correct answers must have the following 3 things. They must have the correct units, they must be rounded off to have the correct number of significant figures, and they must have, they must be written in scientific notation when appropriate. The units you find by using the same units as your endpoint. The number of significant figures is determined by looking at how many significant figures there are in the question. The fact that there are 3 significant figures in the question means that the answer must also have 3 significant figures. And any time that by moving the decimal to after the first non-zero digit, it has to move more than 2 places, you must put it into scientific notation. And you can do all 3 at once. So I know I have to put it in scientific notation, so I take 2.7. Now because that has 3 significant figures, I know I must round off after the 3rd significant figure, in this case the 3. So it's 2.7, that 6 changes that 3 into a 4, times 10, and since the decimal ends up after the first non-zero digit, in this case to 2, and it started way back here, that moves 1, 2, 3, 4, 5, 6 places. I write a 6 exponent. And because this number is greater than 1, that's a positive 6. And then finally, I write down the units of my endpoint, centimeters, and I circle or box my final answer. And that is how you do unit analysis. Now I'm going to show you one more problem that's slightly different, but still the basic concept. Let's say we have a question that is asking now, how many pints are there in 4.73 times 10 to the 4th milliliters? All right, so 4.73 times 10 to the 4th milliliters, and the question is how many pints? Step 1, I have my starting point. It's not an equal sign, excuse me. My starting point and my end point. Step 2, I look up the non-metric unit using the left side of my metric conversion chart. Between milliliters and pints, the non-metric unit is pint. So I go over and I look up pints. And I find them down here. 1 pint is equal to 0.47 liters. So 1 pint is equal to 0.47 liters. Next, I use the right side of the chart to look up any metric unit with a prefix in both the original question and the first equality. Since this question here, the original question has milliliters, I need to look up milli. But since this doesn't have a prefix here, I do not need to look up one for liters. So I look up milli, it's right here. I write down one base unit. This time the base unit's not meters, instead it's liters, is equal to 1,000 milliliters. So 1 liter equals to 1,000 milliliters. Now I set up my chart, my grid. My starting point, 4.73 times 10 to the 4th milliliters. Goes in the top left-hand cell. I have milliliters on top, so I want milliliters on the bottom. They're right there. So I put 1,000 milliliters on the bottom, and that's equal to 1 liter. I cancel that out. One more equality, I put one more vertical line, and I have liters on top, so I want liters on the bottom. So I want liters right there, and I have 0.47 liters, and that's equal to 1 pint. I cross that out. I make sure all the units cancel out that's supposed to. So once I have the equalities, I make sure that everything cancels out that's supposed to. Milliliters cancels out with milliliters. Liters cancels out with liters. I'm left with pints, which is exactly where I want to end up. Now, on my calculator, I go and if the number's on top, I multiply. Numbers on the bottom, I divide. To enter this number in, remember, use your EE button. It might be an EXP button. Each calculator is different. So I go 4.73 EE to the 4th, divided by, because it's on the bottom, 1,000. And then since 0.47 is also on the bottom, I divide again by 0.47 equals. My answer is 100.72 638, etc. Now remember, this is not the correct answer. Correct answer needs to be rounded off, have the correct units, and be in scientific notation when appropriate. Since my starting point has 3 significant figures, I need to round off my answer to 3 significant figures. Also, I need to put it in scientific notation if the decimal point moves more than 2 places. However, since the correct location would be after the 1, I would only be moving it 2 places, so this does not need to be in scientific notation. So I simply round it off at this digit here. So the answer becomes 100, the 6 changes the 0 to a 1, 101, and the units are pints. And there's my answer. I hope you found these videos useful. Thank you.